Assalamualaikum warahmatullahi wabarakatuh. First of all, I want to introduce myself. My name is Agus Suparti from Department of Electrical Engineering, Universitas Muhammadiyah Surakarta. For this time, I want to present my paper with the title Development of an Arduino-based monitoring system for Pico-Hydro power plants. Let's start with the introduction. We and people around the world need electrical energy in our life. Usually, we get this electrical energy from electric companies such as PLN in Indonesia. Unfortunately, people live in remote areas. They cannot enjoy the electrical energy supply from PLN because there is no infrastructure for the power distribution. On the other hand, the available rivers in this area can be used to generate electrical energy. If we want to try to develop the power plant, it should be inexpensive, easy to operate, and reliable. It's better that we equip the power plant with a monitoring system so the user can see the output of the power system plant here. In the study, we try to develop a Pico-Hydro power plants and its monitoring system to meet the power need in remote areas. This is the block diagram of our system. Let's start here. This is the generator. We use AC or alternating current generator. Its output will be converted to DC by inserting rectifier here. This uncontrolled voltage will be regulated by using solar charge controller. So its output about 12 volts can be directly connected to the battery here. The battery is used to store the energy that's been produced by this generator. Here we connect DC-DC step down. It is used as the power supply for our microcontroller Arduino Nano. This is different with this load or consumer. The consumer here needs high voltage about 220 volt AC alternating current. So we install inverter here between the battery and the load here. The inverter is used to invert from DC 12 volts to AC 220 volts. In order to monitor the output of our power plant, we use 5 sensors. 1, 2, 3, 4, 5. This sensor, infrared sensor, is used to measure the speed of the generator. Both of them is used to measure direct current quantities, voltage and current, and this sensor is used to measure alternating current quantities for the voltage and the currents. All of the sensors here will be directly connected to the microcontroller Arduino Nano. We connect these sensors to analog pin, both DC and AC, and we connect this infrared sensor here to digital pin. This microcontroller will process the data that's been read by these sensors here, and the result will be displayed in this LCD, liquid crystal display. So the user or the consumer can monitor the output of this power plant by using this display. This is the test of the Pico-Hydro power plant in the real fields. This is the turbine coupled to our generator. This turbine is rotated by using waterfalls here. The output of this generator will be monitored by our system, and we also connect multimeter here and also clamp here in order to calculate the output of our system. This is the result of the test for DC voltage sensors. We conduct 3 measurements. From this, we can see that the error is collected from the difference between the output of the sensors and the output of the multimeters. And after we calculate the average error, we get the value is about 1.88%. And this is the result of the test for AC voltage sensor. Like in DC voltage sensor, we also conduct 3 times. The voltage measured is about 220, and we also make comparison. We compare the output of the sensor with the output of the multimeter, and then we calculate the error. And after we'll calculate the average, so we get the error is about 5.29%. This is the DC current sensor test. From the times test, we get the error is about 1.25%. Okay, let's continue with the no-load test. For no-load test, we only have voltage. There is no current displayed in our system because there is no current flow through the loads. So the result of the measurement also will be equal to 0. Okay, there are 3 series from this figure. The top here is for the speed RPM, the middle here is for VEC, this is alternating current voltage, and for the lowest part here is for VDC or direct current voltage. Okay, from this result we can see that the speed of this generator is unconstant. This is influenced by the condition of the test, that the water here is common use. It is also used by the farmer, so we cannot control the waterfalls, and finally they will influence to the speed of the generator. This is the result of the measurement of the speed. We conduct the test about an hour, started at 11:42 and stop it at 12:42. Okay, after we rotate the generator from 1300, yeah, until the lowest speed here is 725, so they will produce a DC voltage here, and the result is about 16 volts. Yeah, the other result is also inform us there is some variation, yeah, like this about 14 volts here. On the other hand, related with the VEC or alternating current voltage, the result of the measurement is about 220. There is also some variation related with the output here. Okay, we continue with the load test. Like the load test, we also have three series here. This is for the speed, this is for VEC, and this is for VDC. Okay, we focus here. We focus here related with the result of the VDC. If we compare with this result, yeah, this is about 16 volts. Here is about 12 volts. So this is influenced by the connection of the loads. By connect the loads, so the voltage will be decreased. So this is the theory that if we connect the loads to the generator, the output voltage will decrease. Okay, this is for the result of current measurement easy in DC because the field of the current is almost equal, so the series here is same. Yeah, this is about 1A. Yeah. Okay, we arrive here in the conclusion. The test of the DC voltage sensor, AC voltage sensor, and DC current sensor produces errors of 1.88%, 5.29%, and 1.25% respectively. The node test shows that the system generated a flow of 12.77 to 16.6 voltage DC and 224 to 245 volt EC when rotated at 696 to 1363 RPM. When loaded, the system generator voltage is lower than node test here, about 12 to 12.5 volts DC and 225 to 247 volts AC when rotated at 1332 to 1562 RPM. I think enough for my presentation. Thank you very much for your attention. Assalamualaikum warahmatullahi wabarakatuh.